How we doing today, guys? Let me double check to make sure everything's working. And then once I can confirm that, we'll get started. Okay, YouTube works, and Twitch. I keep thinking that the Nginx server is gonna fucking crash on me, but maybe it won't. Maybe I'm just paranoid. Create our dashboard. Stream manager. God, I love how little latency that has. It's beautiful. Okay. I wish to God, whoever made the fucking Twitch UI would make the bitrate tracker not just pure red. If it's within a good range, just make it change color. Every time I look at it, it's fucking red. And even though that's the exact number that they want, and it's supposed to be good, it still fucking scares me every time. Okay. Let me, now that those are both working, we can show that they work. Let me hop over and open up all the chats, and then we can get started. So pop into here, pop out this chat, and then we're going to put that up there. I'm gonna grab you, and let me pop out the Twitch chat. Let me pop out the stream manager, the alerts. I need to pop out the alerts. Actually keep track of what the fuck's happening. Pop out activity feed. Okay. And put that in the bottom left. Put that up there and put that there. Okay, cool. All the chats are up and running. Everything's good to go. Now let me swap over to Chrome. So that you can see the issue that we're having. So last time I streamed, we had set up like a basic bitch version of the tile system, and now it was basically trying to get some semblance of an AI set up, and then we were going to go back to like map generation and then getting that up and running. But here's the issue. I figured out why nobody is using like AI or like chess AIs for their for their games. I figured it out because I was running the math today. So A is the number of agents we have on the map. N is the number of actions. So if you think of like an XCOM action, you might have like shoot sniper rifle or move or teleport or like any of those types of actions. D is the number of dimensions that you could do. Basically, it's like the direction that you would choose to do this in. Like if you attack with a sword, attacking forward versus right needs to be considered a different world state, right? Because in the idea of doing a chess engine, you need to track each move possibility. So if you do this for all the world states, this is assuming that they're all valid, which would curb some of these. But if we assume, the goal is to assume the worst and then see where we're at, right? So if we assume with just 2 enemies, 10 actions, which is a bit high, but still, we'll at least have a few that could have 8 to 10, and that's enough to be concerned, okay? Because even if we set this to 5, it's still fucked. And we have 9 directions. So 2 enemies, 10 actions, 9 directions. The first world state, or the first depth of the algorithm would have 8,100 world states. And if we scaled it up to our max amount of enemies, which is 256, Desmos stops counting at like around 150. It actually just can't do it. And that's just at depth 1. By the time we hit depth 2, it's actually impossible for it to do it. It just cuts out. So, and even if let's say we went back down to 2, and let's say we dropped the number of actions to 5, which, to be clear, the player will probably have 10 always, or around 8 to 10, because you'll have a standard move, a light swing, maybe a heavy swing, like 1 or 2 special abilities, and then maybe any abilities you find from items, or maybe like character specific abilities or runs or whatever, or like run item abilities that you can find. Like maybe you have like a stake because you know this is a vampire game, so maybe you like have a stake and you can like use that to stab as opposed to using your sword, right? That would be a different action because it would be you're doing a different thing, and so each of those would need to be stored differently. So the player will easily have 8, 10, 12 actions, but and then some of the bosses will have a good amount. Your basic bitches, like your zombies, might only have like a bite, a move, and a grab. But besides that fact, even with just 2 units, 5 actions, and all 9 directions, we would have 2,000 world states. It's just there's no way that this is feasible, and depth 2 is pathetic. You'd want to have like depth 5, hopefully, at least 8. So, God, we hit undefined. Like, not even. What would you, how few actions could you do to get us there? Like, if we did, 3, 2, 1. God, it's not possible. We just can't do it. It's so fucked. Maybe if we drop it, let's see if we drop it to 4 directions. Maybe we don't allow diagonals, okay? Maybe I'm coping right now that we could still do this. Christ. Jesus. That's only with 1 ability. Wish there was a way to say that these could only be ends. 3, 4, 5, 6. The point of the matter is, this style of AI is not going to work. There's a few reasons why that this doesn't work over traditional chess, and I was aware of all of them, but I hadn't actually ran the numbers yet. The first thing is, we have more world state variations because units have more than 1 health. In chess, you move to a spot and the piece dies in 1 action. That's a beautiful action because all you're doing is you remove that piece from the board. But if you can swing and the chess piece lives with 3 health, well, now your world state gets infinitely more complex. And then we have a complication with the number of pieces, right? We have way more pieces than a chessboard. And then the other really big complication is that each piece can do more moves. Because a queen might be able to do, 15, 18, 20 moves, whatever, on her board. But it's like every one of our pieces is like 3 or 4 queens. Because with each action it's 9, so you're basically like a rook almost with, or like 3/4 of a rook with every single piece. Or a bishop maybe. Bishop might get us there, but yeah, this is just too much. So we need to figure out a way to do a new AI. That's what we're gonna do today. We're gonna theory craft out what a new AI looks like. So let me pull up my my streamable notepad. Where are you? Stream visible notepad. Okay. God, that's so fucked. I knew it would be bad. I didn't think it'd be this bad. Oh, and then the other huge thing, which I forgot to mention, is we have sequential turns. So you'd have to consider it's a world state per combination of every move together, which is the really big exponential factor right here. It's this fucker. Because if you remove A, it gets so much more manageable. But we've made it a rule, or at least I'm going to try to make it a rule, that the enemies go sequentially, because it's too important to game feel. It's too critical. It has to be this way. I would rather. I think the project would have to basically completely be reimagined in order for it to not be that way. It'd basically be an entirely different project at that point if I didn't do it. So that's a pretty hardline rule that we have, which is gonna. That's so wild. Oh man. I did that math right because it x. Yeah, because it's the nut. Yeah, I think that's right. This formula might be a little off, but it's not going to be by much. um, I tested out like a few, like if I drop the amount of agents to one and the amount of actions to one, the amount of inputs and whatever, and I calculated out like something like this, like 3 steps for each of those, and then kind of did the math to figure out a little bit of a trial and error to get it there. But it is it's not pretty. But okay, so I was thinking about alternatives. One idea that I was playing around with, I went and started watching different GDC talks on how they handled AIs, and there was one that I watched yesterday and today, where it was like a group of micro talks. So GDC will do this kind of talk where like they'll get 5 or 6 devs from different companies, and they will give like a 5-10 minute talk on what they did with their thing in regards to an overall theme. And one of those micro talks was about XCOM, because I was curious how they did the XCOM AI, and what the XCOM AI guys did was that they would evaluate the result of an action around like a quality of criteria. So like for cover, it would be like I think it was angle, distance, range. So that's like how far away you are from the enemy, how many enemies you can shoot, how many enemies you have an angle to flank. Also, what's the actual angle of your... so there was flank and angle. Flank was how many enemies you were flanking, and angle was how good your cover was against them at that position. So you don't want to like run out into the open if you can shoot them all, but if you can hide around a corner and have a good angle, and also be able to flank all of them, that'd be the best spot. And then there was like 1 or 2 other variables, but one of the things that I thought would be interesting, I don't remember what exact point brought this on, but I had the idea of making different weights for the algorithms based around kind of like a state, but instead of the state being like is aware or basically just making a distinction between the states of like doesn't know player, suspicious of player because it's like hanging out like a stealth mechanic, aware of player, in combat, hunting, right? Like instead of having these be the states, which they could also be a state thing, but we have a different set of like algorithms that are built around a motivation. So, and these I thought would be way more interesting and way more indicative of the kind of behavior that I'd want to see. So the dumbest version of this would be like sleep or lethargy. And so that would be for like zombies, right? Zombies don't really want to move. Like if you have like the fast zombie type, sure. But for like a slow, kind of pathetic zombie, it kind of just like doesn't really want to do anything. And anytime it's forced to move, it'll typically like... It's very easy to de-aggro a zombie, right? Because once it loses control of you, it kind of just goes back to being idle. But then if we have like hunger... A hungry enemy will fucking go after you. They'll be incredibly aggressive. They might stalk or hunt you. They might even get like do more aggressive trades that normally like enemies wouldn't do because they're so desperate to fucking feed. And then you had like I made a list. Hold on, let me see it for this. Sleep, hunger, commitment. Commitment was basically like it's kind of like duty or honor. But basically, the idea of like, I am a knight who's bound to protect this crypt, or I'm the butler of Dracula's manor, and so my job is to keep the riffraff out. And so like they would guard objectives more. They would care more about player progress and preventing that. They would focus like stopping the player's progression is more what they're worried about. The player could die or be useless, and they would still be happy. Now, with some, we might tick that up a bit more. Like, obviously, it'd be a little bit better if they were dead versus, or a bit better if they were dead, because then they wouldn't be a problem anymore. So you might make like a scaling factor of like how many problems they've caused makes them weigh more heavily, but that's kind of what you're already doing anyway with the objectives. But something along those lines I think would be interesting. So that like one's more objective focused. Then there's thrill. I feel like enemies that are thrill focused would be much more they're not necessarily aggressive, but they're more focused in like a dynamic change in values, right? So it's more interesting to them if you will parry them or if you'll dodge. Combat will be a huge must for the thrill, but also hunting will be like really fun for them. As long as they constantly feel like there's some kind of cat and mouse game, or as long as the AI is designed in a way such that it's trying to optimize for actions where the game continues and the game is fun. So like here's an example, right? Let's say that we were in a scenario and the player slashes an enemy and then runs away. A commitment enemy might spit out a dialogue line, like, fuck, he's going for the armory, and they might dash to the armory to go find them. While like a thrill enemy might spit out a line like, run while you can, and then they'll like start following the blood trail, or they'll like start listening for noises, or they'll like get into like a hunting mode. Like they will have radically different behavior just built around this same principle, I think. And so then there's sadism. And sadism, there are going to be enemies that are just stronger than the player in this game, and sadistic enemies are going to be enemies that just want to fucking torture the player. So, it's like thrill, but the distinction in my head is that sadism enemies won't try to kill the player. They're going to be way more likely to taunt the player. They might value not killing the player higher than killing the player if it means the player lives longer to take more damage. Does that make sense? Like they're openly embracing the idea of just kind of fucking with the player. And they're just kind of like a constant thorn in your side. And then like the play pattern would be is that a thrill enemy is like a real challenge that's constantly fucking with you. A commitment enemy is like a serious foe, and so you have to like worry about where they're going to be and how they're going to stop you. A hunger enemy is just like a chaser that you just have to stop. And then like a sadism enemy is going to be like a constant obnoxious fucking force who's like okay letting you run away because they're going to go to a spot they think that you'll be next, and they're going to try to set up like a trap or fuck with you or stab you so that you bleed and get slowed for a bit while the zombies like pile on top of you. Like I feel like a sadistic enemy would have to have some values about making it more fun for them if another enemy kills you. So yeah, I think that would be a thing. And then finally anger. And anger is just like anger would probably be a state that is triggered after the enemy fails a condition for another state. So if you manage to break every vase in the manor, the butler might turn into anger. Or if the sadism enemy has lost control of the situation and is getting their shit kicked in by the player, they might turn to anger. And this state is just incredibly aggressive, and it's incredibly forceful, and it's just trying to fucking kill the player. Like, there's no ands, ifs, or buts about it. It will do the most aggressive, most lethal option every single time, with no hesitation, maybe even for their own life. So, yeah, I think those are the... Oh, and then I need to add another one, which is fear. And fear is like you have an enemy on the back ropes, or the enemy is terrified of some ability you have or whatever, and they need to flee. I think these are like I think it'd be interesting to try to approach it this way maybe, because then you can weight these entirely differently. And so the idea would be is that you'd have like a function for each of these, and then you could feed a unit to one of these methods or functions, whatever, and then it would produce like the weights differently or the action choices differently than another unit or than another one of the states. And then these could mesh, right? So like a thrilling seeking enemy, if they're suspicious of the player, they're like much more likely to kind of just run in and like jovial, like, oh, where the fuck is he? Let's get this guy started. While a sadism who's suspicious of the player might do something similar to thrill. Let's see, would be a different one. Oh, fear of the player would be fucking running. Like they hear any noise and they fucking book it. Um, so yeah, I feel like these would be kind of the fear would probably have to have a condition for whether or not they're like cornered. And if they're cornered, then they'd probably just like do like a lash out, which would probably look pretty aggressive like anger, but it's not. Because I feel like they would be way more defensive, right? Like it's not going to want to like take trades nearly as much. Because if it can get out of the corner by being aggressive, then it'll do that and then keep running. But yeah, I think this might be an interesting approach. The issue is I just don't know how to not end up with this world state issue. Because I need some way to consider the future. So it's, hmm. Yeah, fuck. I need some way to do it. I guess it's possible if I don't end up considering future world states, then there has to be I guess theoretically I could consider each world state separately of each enemy. Like each enemy conceptualizes what its future looks like in a few turns, and then just ignores what the enemies are doing. And then you just like when you go to process the turns, you process them by order of tier, right? So the most important enemy gets to go first, and so you kind of have like future turns set up in case one of your actions is invalidated. So like let's say that you have a a 3 act turn per unit like elite enemy and a 2 turn per unit boss. The 3 turner does its first turn. Then when the 2 units, the elite and the boss would go simultaneously, the boss goes before the elite, and so the elite has to have a backup ready at this world state and for the next thing it would do that would be valid. And you kind of just iterate through that. Um, Something like that, I think. But let's see. It's also going to help, I will say. It will help because not all enemies will go at every tick, right? So that's going to help a bit too. Now, is it going to be enough to beat this issue? Oh, like a little bit, but... I think I still have to fix this issue, even if I do something like this. Okay, let's go back to this. Let's say we have 2 enemies. Let's say that there's a total of... Let's say each of them has 4 actions. We'll do a basic move, 2 attack types, and a block, right? Okay. Then we'll throw in 9 directions. Okay, at step 1, we have 1,300 world states. Okay. How can we simplify this down? Well, I would assume based on the geometry of the map that at least one of those moves will be invalid per guy, probably. Just because if you're up against a wall or something, you can't run through it. So we would drop that down to basically, well, no, it would be 4. You'd have to cut one of the 9 down to an 8 or a 7 or something. Fuck. No, we have to calculate maxes. We need to evaluate this based on the max that it could be, and then go from there. The other issue, which we haven't even discussed tonight, is memory. To hold these world states. Because if you hop... Oh, wait, let me turn off the Chrome thing real quick. Or no, I guess I don't need to. Fuck it, hold on. Let me go to the world state. So this is the world state struct that I was theory crafting. So a value, obviously, is the return value for how good it is. Then we have to have a health offset, right? So we need to be able to track the health difference between itself, the player, and any other enemies. Because it could be that we end up hitting other enemies in the process, and then we want to devalue that thing, so we would hit an ally. So we need to then store... and also, depending on how many enemies are going, like, if one enemy is firing an arrow, and the other enemy is swinging a sword that's going to hit a second enemy, we would need to track the damage the arrow is going to do to enemy, like, 4, and also the damage that the sword is going to do to, like, enemy 3. And so we have to basically store every single unit's health offset. So that's 256 bytes. And also, like, if they have, like, a heal or something, that's going to change, too. So it has to be positive or negative. Then we have a position offset, so that's the or that needs to not be EUENT, that needs to be ENT. It doesn't matter. That needs to be the distinction in how much you've moved since the last time. You could, theoretically, drop this down to an S byte, because that will reduce the amount, and you're not often going to go more than 100 something in either direction in any combination. So I could probably store that as an S byte, but that doesn't help our problem. Because action arg is a, what is it, a 4 byte struct. So basically we're at 6 times 256 plus 2. Which is 1538. So if we go back up to here, 1538 times 1296 is almost 2 meg. It's almost 2 meg of fucking world states in just one depth. And that's assuming we don't do this. God, it looks like it's like what, 3 gig? So at depth 2, we'd have 3 gigs of fucking memory. Oh god, kill me. um yeah, I don't think we can do world states. I don't think it's possible. Ten to the 9. I think 10 to the 9 is a byte to gigabyte is 1 to the 9. So yeah, that's about 3 gigs then for depth 2. Okay. Or 2.6, but so what we need to do. Okay, let's pull up the notepad. Let's do some thinking, some thunking. So we need a set of states based on awareness, set of awareness states. Then we need a set of motivation states / algos. Each enemy would also probably have a set list of these motivations it can store, right? Like an enemy, like a zombie, is never going to be sadistic. It's just not smart enough to be that. Maybe there's gonna be like a unique zombie that's allowed to, but like your basic bitch zombie is just never gonna have that AI pattern. Or even if they did, I don't know if they'd be able to take advantage of it. So we have a set of awareness states. We'd have a set of motivation states / algos for each of them, and then we did a way to store future world states / store / check. With as little memory as possible. And then we need a way to reduce the number of world states considered. Theoretically, we could treat this kind of like an A star, where we have like, A star is start. It's evaluation of start to tile plus an evaluation of endpoint to tile, right? So it's the F plus the, or F is equal to G plus H, I think is the lettering. So maybe instead of having, maybe what we do is we do a set of world states in like a node style, and then we evaluate them based on an initial heuristic, some initial score of how useful do I think this could be for me, and then based on that as our F, then, or as our G, then we start doing the G's first, and then we do one check below them and total that, and then return it. So we're not actually it is recursive, and we are conceptualizing those world states, but we're not we're basically G1 is equal to the average of, or the what would be the worst, the best of G2 or whatever. Do you understand what I'm saying? Like, we're just kind of going back and forth. Fuck. And we haven't even talked about the fact that this is at that these enemies will have multiple actions a turn. Fuck. So we're actually missing a dimension to this algorithm. So yeah, I guess we don't actually have to conceptualize all of the variations on all of the world states if we just what was the chess programming term? If they're pseudo legal moves, if we don't check to see what they'll be after we've performed them, their legality. We do that when we go to perform it, we'll start filtering that way. That could be huge. We also could do a hybrid, right? So let's say there's only one enemy who has that speed, who's going to get 3 turns this round. Maybe that enemy gets to do their first turn and lock in that first turn, and then we start throwing in the or maybe like at each depth we check for which enemies can go. I mean, which we're going to do anyways, but maybe that would help solve the issue a bit, because the first enemy is only going to be what is it, one enemy, 40, it'll be like 36 world states, up to potentially 90. So that's way more manageable. And then we could, and then after that one, then we start filtering in the other enemies that will, chunk us out more. But is it, if I do x plus 1, that does nothing. Okay. All right. Let me make sure I can see chat again. Okay. Fuck me. We just store / check future world states as little memory as possible. Okay, let's get creative. Every enemy will have maybe if we could reduce the size, like an S byte isn't really necessary. You're going to store each enemy's health is currently a byte because it's the smallest that can store it, but we're only going to have I don't even know if Dracula will have 100 health. Maybe he will, just because he's like a final boss. But like, enemies I don't think are going to have that much health. The numbers are going to be pretty small. Maybe for balancing, I'll end up scaling it up a little bit so that it's easier to manage. But I can't imagine needing a full byte. Or I guess if I allow up to 100 health per enemy, then necessarily I have to have at least an S byte of health offset, because it could be the case that they die. So that would be minus, 100 or whatever. Okay. Okay, so I think the first thing, let's start with easiest and work our way backwards. The first thing that we need to conceptualize is that turns need to, or the world state needs to be smaller. I think we can all agree with that. So let's start there. U short's max size is let's see, you're going to want the number of a score of a thing to be able to go into the negative because it implies that it's truly just worse for you. 0 should be neutral. So instead of having a U short, we could do a short between negative 32,000 and 32,000. But that feels like too much. I don't think I need that much. An S byte between negative 128 and 127. I don't think I'll need anything bigger than that. Because it's all going to be relative, right? So as long as I can keep... I say that, but I might actually want these to be... Hold on, is there a floating point numeric types? I might actually need these to be... needs to be a bit more precise. Floats are 4. That's our minimum. Okay, I think I have to change this to a... Let's do a short for now. So we keep it at 2 bytes, right? It's 2 bytes. Yeah, it's 2 bytes. And then what we'll do is, what we can do is anytime that we would use a decimal, we can just, we'll multiply the larger numbers by a value of 10, and then the small offset numbers. Because I remember like the example that he gave in that one video. What was that channel called? Sebastian Leg or Log or however you say that. For his chess engine was that the knights got bonus like decimal points as they were closer to center. So if we were to do something similar, we would set our maximum point types or our normal point types to 10, and then these weights that we would give them would be like our ones places that we could use to offset it. We could also just int round down, which would help cut that as well. So once you get a bigger number, then you'll have more room for that. Okay, so we're going to have a short for value. Public unsafe health offset. Okay. Can I get away with not using 256 bytes for this? Theoretically, I could make a struct which is going to contain a byte for an ID and then an S byte for the diff or health diff. Wait, yeah, health diff. So that would still be the same number of bytes, but now we don't have to store 255. We would, most situations, get away with... Okay, let's think, what is the most damaging thing you could do? Like an AoE spell or an AoE heal? And let's say that the AoE heal is... I don't know. You're a necromancer, and you can AoE heal 40 enemies. Okay, so if we have 40 enemies, that's going to be 80 bytes. And that's a lot of enemies getting healed simultaneously. And most enemies on the map aren't gonna... We're gonna try... I think I'm gonna have to start not processing enemies when they're not in an active region. I think I'm gonna have to do that, because it's just... I think it's gonna be too much processing power and too much memory shit. It's gonna exponentially increase our world state. Let me add that to my notes. Deactivate non-active player regions. Yeah, I think we're gonna have to do that, because otherwise this gets so fucking complicated. You might also be able to simplify it, right? Like an enemy who's not in the same region as the player, has no idea where the player is, and is like most zombies are going to do one guaranteed thing. They're not actually going to even consider possibilities that much. They're going to like do like a quick check and be like, okay, this is the best option for me. Like a depth 1 for those is a depth like 5 or whatever for other things. The worst thing would be if we had an enemy that's like a hunter enemy and we assigned them a position of like last seen player location, and then that enemy like would go to the last seen player location, which might be in a previous region. So like I'm imagining, let's say there's a hunting mechanic that starts every night, and then let's say like one night it ends while the player is in like a crypt region, and then let's say the player leaves the crypt region, heads 2 other regions out, and goes into like a garden. Okay, now when the enemy comes back the next night, they start off back in the crypt again, trying to pick up the trail. They'll have to pass through 2 regions before they get there. I guess you could abstract it out, right? You could do like a different processing thing for like enemies in other regions, where if they're like hunting the player, then they might check every so often to see if they come in, or if they're, you know, a neutral enemy, then they just kind of fucking hover around, and then whenever you come back to go into that region, you like shuffle them around a little bit. Something like that. Okay. So yeah, we can get that down to about 80 to 100. And that'll be pretty big. I think if we do this, though, I can't set the layout type to explicit, although I really want to. Or maybe I just make a bucket for it for how big I expect it to be and never get above that value, and then we can work in it that way. But that's going to shave us... What, it was 256, and now we're going to be down to 80. So that's minus 176. So that'll be pretty big. Man, if 40 enemies were having or 40 units were having modified health, I don't think we could get above that number. I don't even know if we get like 25. Like there'd have to be like a map-wide healing effect in order for this to happen. Position offset, I don't think you can get smaller. Maybe disable the one for active enemies again, so we do a similar thing of like public struct position offset, and then we do public byte ID, and then be like public s byte, or no, it would be s byte 2. Fuck. So let's see. We would have been 512 bytes. And now with this, how many enemies would be able to move simultaneously? Let's say that an active region has like a spawning focused unit. So I'm thinking like a zombie region or a skeleton region, a crypt region, a necromancer region, something like that that's going to spawn a shit ton of ads. Let's say that there are what? The game is more scaled down in the minute to minute, right? Like in Resident Evil, you're never having more than like 10, 15 zombies, and that's like in a really big encounter. So I feel like it's going to be something similar, where the survival horror game is going to be pretty on the lower end, because that many zombies is going to fuck up a lot of characters and players anyways. So, especially if it's in a more tight-knit area. So let's see. If we had, let's go with the 40 number. If we had 40 active players, that would be 120 bytes. For 40 active characters, be 120 bytes. Let's do for simple numbers. Let's go to 50. Just to keep it real simple. And so that'll be 50 times 3 is 150. Okay, so then we'll be at minus, I'm not doing this math, 512, oh, delete, 512 minus 150, 362. Okay, then we could do moves. I guess we could also make this a hash map. Would that change the of ID to value? Does that change the memory at all? Hold on. What is the memory footprint of a hash map C#? If your keys and values are objects, there's approximately 20 bytes of overhead for each element of a dictionary, plus several more bytes per dictionary. Okay, hold on. I want to use the unsafe hash map that Unity has. So let's do unsafe hash map Unity. It's a struct of type key to type of value. Well, if it's a struct of key to value, then I feel like it'd be safe to assume that it's... Hold on, let's pull up the code. We'll do this. Public unsafe hash map of type byte to S byte. Yeah. Okay, quick definition. Public unsafe struct, native disposable, enumerable, unmanaged, how much memory does an IEnumerable use? C#. If your question about memory allocation, there's no difference in memory use between IList and IEnumerable. I guess we could just like, let's delete this explicit layout. Let's delete public, delete that. We'll just delete all the field offsets real quick. I just want to do, let's go into, we'll go to spawn system. Right here, we'll just write bsd.valueReadWrite in here we're modifying the world states, so I'll do it here. I'm going to actually need this to resolve, so I'll just change this to true. Okay. And then we'll go into here and just right here. We're going to say WSS dot. What do you mean it's oh no, WSS bracket 0 dot val dot value. Fuck, hold on. Oh no, not value. I want dot test. Or is it Marshall? Fuck, how do you do size of? I think it's Marshall dot size of unsafe hash map of type byte s byte, and we'll just debug.log this. Size of array is fucking bot. There. Okay, let's reload this. It might say 0, so I might have to make the array first before we test it. Actually, let's do that real quick. In here, we're simply going to say, instead of this, we'll just replace this with WSS bracket 0 dot test. And then before it, we'll say WSS bracket 0 dot test is equal to new of type with 50 items of allocator dot persistent. So theoretically, this should return 150, which means it is a true struct, and it is impossible for this to. What is the issue here? Indexer temporarily returns value. Okay, hold on. There. Okay. Reload. Let me make sure that is this working? Okay, cool, we're in Unity. Why are we frozen, buddy? Unity? Oh, well, okay, guess we're closing that down. Well, that's fun. Do we have a fucking infinite loop or something in here? Why did that do that? Okay, let's delete. Let's just get rid of this shit, okay? It's not relevant. Oh, I also don't need, I only need one of you. I don't need 100 of you. That'd be fucking ridiculous. Way too much memory. Okay. Size of array is 64? Huh? How the fuck is that true? Unless... Well, no, because when you set a capacity, that's the max value. Hold on. We're putting some breakpoints here, and I'm gonna attach. I don't understand, because it should be... It's not like it should be an empty hash map. It should be a full hash map. Or not, the length should be 0, but the memory allocated should be 50 for it. So I don't know why... Okay. We have created the hash map. WSS items 0 test raw view. Oh, we have to step through one. Wait, the capacity was still 0. Hold on. Did I do this wrong? Okay, let's save this. It still says 64. So then it did have the capacity set up right. Hold on, let me go back to my notepad. Yeah, this should be 100. Why does it say it's 64? Okay, so now we've added an element. How does it have 2 raw views? I don't understand what the fuck is happening. Hold on. Go back to Google. Size of unsafe hash map. Unity. Okay, yeah, hold on. Let me debug.log the capacity, because I am... That's not a bad idea. Debug.log ws bracket 0 dot test dot capacity. Debug.log ws bracket 0 dot test dot count. Okay. Surely I will see an interesting set of data here, right? Okay. So at line 84, the capacity is 256. One for each byte. Well, no, that doesn't even make sense. We set the capacity to 50. So that should be 100 bytes. Then we said, this is capacity, right? Yeah, initial capacity. Is there an add no resize here? No. Size of array is 64. And the count is 0. How is the count 0 if I added one here? Is it read only? Modify a value of a dynamic buffer unity. Oh, they're always read only. Okay, well, in that case, let's just where's the error? Oh. Oh, there's a memory leak. Fun. Okay. So it still says the capacity is 256, which doesn't make any fucking sense. Then the count is a 1, and then the size of the array is 64. Unsafe hash map. Quick definition. I need to... I'm trying to figure out how the fuck it's 64. Does it always dynamically scale? Even if you don't, even if you set a capacity? And maybe it always rounds up? So, like, hold on. If we're at, let's do 50 elements, each element would be a total of 2 bytes. That's going to be 100 bytes. Well, then why wouldn't you stop at what, 28? Why would you shoot all the way up to 256? I don't get it. I don't understand. Hold on. Hash map helper m underscore data. Hash scripting API. Hash map helper. Oh, that's not in their documentation. Unsafe hash map. What is this fucking thing? Safety enabled, burst compiled with safety enabled, burst compiled with safety disabled, base class library. Okay. Is empty. Can I scroll this? Yeah. Let's see. What is the unsafes? The fact that the table doesn't fucking keep these on the left so that I actually can't see it as I go to the right is absurd. Okay, unsafe hash map. Interesting. Oh no, safety disabled is the okay. I thought that was never mind. Wait, these are so much faster. How do you do that? Oh, is that just a standard dictionary speed? Okay, and then those, the unsafe list shines through. So for this, it seems like unsafe hash set generally does better. Okay. Parallel hash map. This thing's gotta be fucking gaudy. But it's probably with this one. Yeah. Parallel hash set. Oh, I'm fucking. Hold on. I just realized I'm looking at this and you guys can't see it. Enable. There we go. I was looking at these differences in performance on different containers. Okay, let me go to. So these are the processing timers, which I definitely appreciate. Don't get me wrong. Okay, well, where's the memory? I have to see the memory differences. Where do I see that? The temp is the fastest. Cool. Good to know. Doesn't have persistent on here, which is interesting. Oh no, that's the last one. Oh, interesting. Persistent's the worst. I guess because you have to like find a spot to store a pointer that lasts long term in some regard. So there has to be like a checker on it and a whole bunch of overhead bullshit, basically. Okay, where is the section about how much memory these are? Fuck me. Okay, hold on. I'm gonna go to the bathroom. Let's turn this back on so that you can see the AFK screen, and I'll be right back. Oh no, is my AFK macro not working? Okay. I think I need to change the timer on my AFK checker to make sure that the input delay doesn't occur. That's good to keep in mind. 8 collection types from safety checks. Okay. Let me turn back to the data, and let's pull up a notepad. Okay. The hash map might be less memory. Actually, you know what? Let's do the practical test. Let's fill it with 50 items and then compare. So we'll do, fuck the capacity memes. For int I is equal to 0, I is less than 50, I plus plus, test.add I comma 5. Oh, I have to cast it. Okay. So now that we've cast it, it should. Or hold on, let's see. Let's see what it says, okay? So capacity is still 256, which makes no fucking sense. Count is 50. Size of array is only 64 bytes. I feel like that shouldn't be possible. Is it just a bucket of pointers? And so the memory is stored somewhere else, and so we can't track it? C# trying to get size of dictionary in bytes. You could use system.gc.get total memory. Okay. Yeah, fuck it. Long mem is equal to gc dot get, oh, here it is, dot get total memory. True. And then after this, we'll do debug.log. Okay, recompile. I need to understand, okay? I don't get it. Okay. What the fuck do you mean 0? How is the difference 0? Oh, it declares the second phase as 0 before it does this? Why would that matter? Okay, hold on. Let me go back to fucking OBS so that you guys know what I'm looking at. I need to figure out how to automate that. It's so fucking annoying. Okay, June 06. Fuck me. Find the size of a dictionary. Not in Python, in C sharp. C sharp. Not Python. There's a dash. Is it dash? Yeah, fucking hell. My brain is actually fried. I don't understand. I feel like I'm missing something really obvious. Did I name the variables wrong and I'm accidentally grabbing the wrong thing? No, we are referencing test, which is an initial capacity 50 hash map. For some fucking reason. It drops up to 256. C sharp. You guys can see what I'm looking at, right? Okay, good. C sharp collections memory size. Talk about memory allocation. We wasted. You spend more memory. How's. Oh, because it's gonna keep adding. It's gonna keep doubling it until it gets what it needs to fill. That's why. So you've tripped some point that you now, yeah. C# data types. Please tell me you're going to talk about collections. Control F, collection. This reduces memory use because it means that all the processing filtering of the data can happen without ever needing to collect all the data at once. C# is not with the additional span class. They're probably a way of accessing contiguous memory. I don't know. Okay. Let's go into here. Turn off. Oh, fuck. Okay, let's pull up our notepad. So if we do it in an array, we'll drop down to 100. We do it somehow. If we do it inside of a hash map at 64, 150, and then moves. So these are a 4-byte action. I don't think there's a way. I don't think there's a way to limit that anymore. Because the action args are pretty basic. So I feel like that should work. what are we looking at? What's our total now? If we, let me hop over to, okay. So if we have 250 plus, oh, how many moves are we doing? I think we said each region would have at most 50, so that's 200. So we're down to 457. Let's hop back up into here. Yeah, that's much better. So wait, what was it before? It was 1538, so we've dropped it down to a third, basically. Versus 1538 was the original. Okay, let's hop back down. And okay, then we're going to go. I just wanted to write this down real quick for the action args was going to be 200 because it's going to be, well, no, it's 250 or delete 256 times 4, not divided by 4. And 24. Okay, so this would have been 1024. That's now going to be 200. Oh, that's not 457, that's 452. So yeah, now we can fit about triple the world states. That's pretty big. And honestly, we might be able to shrink those down to 25 each instead of 50. But I kind of want to leave it at 50 until we I feel like we could do 25. But I'll keep it at 50 for now. But at least as like a max case reference, and then if we end up never needing that, then I'll drop it in 25, and that'll add us another we'll double again the number of slots we can have. Okay, I think we did pretty good, at least on the memory reduction. Reduce the number of world states. We could individualize it. So if we individualize it, let's do that math. That means that, let me pull up the previous math I'd done. Let me pull up this one. So this one currently has what we would be doing is we would change the value of this exponent, which would change a lot. Because the second this hits 2, it's fucking nuts how much it changes. Okay. Okay, let's pull back up. Okay, so what we would want to do is, oh, I should also probably see chat again. There we go. Okay, so let me scroll down. I'm just gonna paste in what I had done previously. If we assume at most 50 enemies are going to be active simultaneously, maybe we keep it 256 just in case, like, maybe we reduce how much the enemies are going, sure, because they're not active in the scene, but maybe we still keep it 256 in the assumption that some chunk of them will run in the background, because it's not going to be nothing. But we could also do, let's do 50 just for like the active scene to kind of theorize that out, I think. So we'll do active scene, and then we're going to have in is still about 10 actions. That's fine. Direction's still about 9. So we'll keep those. So we're just fucking, okay. So then what we need to do is, let's think this through. If we don't consider the combination of all of them, and we just process it as we go, then instead of this being A1, B1, it would instead become A1, B1. And so we would have 2 actions. Then on this, instead of having A1, if we have, so it was 3 actions, 2 agents. Be A1, A2, A3, B1, B2, B3. A1 through 10 is still 10. And then if we added directionality to this, then we would instead have A1 up, A1 down. So this was assuming there was 2 directions for each action. A2 up, A2 down, A3 up, A3 down, and then maybe the exact same thing but for B. So that would be a total of 6, or 12, I should say. Okay, so assuming that it's just action and agent, it's 1. Okay, so we'll do f of G is going to be equal to okay. We'll change this now to n of x. So if there's 1 action and 1 agent, it's 1. Okay? If there's 2 agents and 1 action, it's 2. So it seems like it then becomes A and X. Because if there's 3 actions and 2 agents, that's 6. That'd be 10. And then when we compute variations, of direction. I think it's just multiplication. So it's 6 now, so it'd be 1 agent, 3 actions, 2 directions. I think that's just AD and X. F2 of X. Okay. And then we'll make a new table that is X. And this will be F2 of X. We'll do 1, 2, and 3. Okay, and now if we set this to 2. Insane difference. Okay, and then we'll set this to 8. Okay, and then for the big boy test. Even that is not as nearly bad as I thought that would be. And then if we set this to 50. So maybe we can still do future planning in world states. I think that's a must. I think we're proving now that we can. We just can't use the chess methods because it's the least optimal way for us to do this. Okay, so that's oh wait, no, this needs to be recursive. So I think it's still ADN to the X. Well, wait, hold on. Did that change that? Because it shouldn't change the first number. Okay, it did not change the first number. Fuck. That's still a lot of world states. Let's replace this with a table. And we'll name this X, and we'll make this f of X times that data was 1538. Okay, yeah. Divided by we'll do the whole thing divided by 1x 10 to the that way we can get the amount of gigabytes that it'll be. let's do the new memory size. So we'll add a new one. Bring it up here, name it M is equal to 1538. Delete U. And then we'll do divided by okay, and then the new memory that we had was going to be 452. Let's do 10 to the 6. So that'll be megabytes instead. Okay, so it'll be 2 meg of memory. Yeah, so I think the only issue that we could run into is hold on, let me make sure I have my formula right, because I think I might not. Because I'm just realizing I never tested these numbers at depth like 2. So if we have one agent and one action at depth 2, it's just the action again. So that's 2. And then if it's then we'll do A1 and then we'll do A2, and then A1 will lead into A sub 1 A1, and that'll lead into A sub 1 A2, and that'll lead into A sub 2 A1 and A sub 2 A2. Okay, so if A is equal to 1, N is equal to 2, and D is equal to 1. And X is wrong. For the worst. Oh no. Oh, fuck me. So with this, the result of this X is 1. And the result of this X is 2. Which then produced 4 outcomes. Or no. Let me back up. The better way to say this is X sub 0, or X at 0 is equal to 1. X at 1 is equal to 1. X at 0 is equal to 2. x at 1 is equal to 4. So is this true if we follow this on? A1, A2, A3, A1 underscore A1. I think it is A2 underscore. I think it's squaring it. Or no, it's multiplying it, the amount of results, by the previous x. Hold on. Let's test 4. A to the 4. So we're going to do I think it's going to be 16, but let me just double check real quick. Okay. So at A0, or at X0, we have 4. And at X1, we have, I think this is 16, because this is 1, 2, 3, 4, 5. Yeah, that's 16. So each value is getting multiplied by the results of the last x. So what this should be, actually, instead of a to the x, is times f to the x. Fuck you, ad block. Why are you popping up? F to the x minus 1. And then we'll add a base case where f to the 1 should be equal to I'm dumb right now. Hold on. 1 agent, 2 actions. So 1 agent, 2 actions is was this one, which means that a x of 0 was 2. Okay, and then we're going to copy this formula into, or no, this formula is already here. So at 2 would be 4, and if we swap this to 4, we did it wrong. If we did this at 1, then we get 1. Oh no, it's still wrong though. Because you would expect 2 to also be 1. Because as long as a is 1 and oh no, n is 2, that's the issue. If I set n to 1, then it's 1 statically. That's true. And if I set n to 4 actions and set f of 1 to 4, or no, this should just be f of 1 equals n. That's what this should say. Now as I scale it, it changes. Yeah. Or no, f of 1 is equal to an. That's what it should be. Because that's correct. Because as n goes up and as this goes up, yeah. Because if I do A1 B1, that is 1. And that will stay 1 forever. Which I think is correct. Actually, this should probably be n to the a. But let's see. Yeah, because that'll be one step. As long as the action's amount is 1, you will always only have one world state to perpetuate into, because that's where all the variation comes from. So I think this is correct. And then if you have 2 actions. Thank you for the follow, Gemez Menti. I think that's how you said it. Games Menti. Appreciate it. Okay, so then if you have I'm blanking now. Fuck. Don't stream, kids, you'll lose your concentration. Okay. So then if we swapped it in, we do A1, B1, A2, or A1, B2, A2, B2, no, what? I did this wrong. A2, B1, and then A2, B2. So on n is equal to 2, b is equal to 2, then the first one should still be 4. That's correct. Yep, that's right. And then the second one will be 16, because we'll need to do this again every next time. Yeah, so that's the correct formula. It's not to the x. I don't think that'll help our case too much. Because we still get pretty fucked. Okay, wait, hold on. Something is wrong here. Oh, this needs to be d to the na. There we go. Yeah. It just needs to be the base number. And then go from there. And then this should similarly be fixed. And this should say f to the 2. And then f to the 1 will equal 80n. There we go. Appreciate the first time chatter, Games. I'll have to pass on hitting you up on Discord. Sorry about that, but generally make a policy of it. Not hitting random accounts up on Discord. This kind of looks like a bot, not gonna lie. Unfortunate. See if he actually says anything back. Okay. Okay, how did our oh, I need to add a table for this. Hold on. I forgot to add. Give me this table. And we're gonna set this to where did my graphing go? I guess it doesn't graph recursive functions. Fair enough. So it'd be 10 megabytes at max. I think if I understand that correctly. Because I set this to megabytes. And then let's go down to 50, because I think that's a nice soft cap to set. That's still about 2 megabytes. Okay. Alright. Depending on how fast I make this algo, this could work. I don't like the idea that depth 2 is an automatic 9 gigs. That's fucked. That's real fucked. I might have to drop it to 25. If I drop it to 25, where do we end up with? So if I drop it to 25, what does that make this? Let's see. So these are all assuming there's 50 items. Yeah, so that's gonna be, let me see this out. Okay. So on this calculator, it'll be 2 bytes times 25 will be 50 bytes. Plus 3 bytes times 25 will be 75 bytes. Plus 4 bytes times 25 will be 100. Plus 2 will be 227. Okay. Okay, we can get down to 4 gigs. 4.5 gigs. And that's only with 50 enemies? I mean, 50 enemies is still a lot. I guess it would also help. Not all those actions are going to be valid. And so that's going to curb that as well. But this means that at least you would have to check the conditions for these world states at least that many times. Or at least this many times, I should say. Because that's the amount of world states. This is the amount of memory. So... That's fucked. Can I make another column? Oh, I can. Let's do this. Let's make a new... I love Desmos so much. It's such a nice thing. Add an expression. We're gonna put this up here. We'll name this M2. This will be M1. Set this to M2 times M1 times okay. And then we'll make a similar second column here. Set that to M2. And then we'll set M2 is going to be equal to okay, so this is just almost half, basically half of it. So that's not as useful. What might be useful is instead of calculating just comparing the memory, because less memory good forehead, it might be better to calculate out how many stages we'd have to look at if we curb about 80 of the results. Or we curb about... Well, let's do the theory craft, okay? Let's assume, for the sake of argument, that you can always move in every direction, right? Let's assume there's no walls, we're in an open field, so you can move 1 in every direction. Okay, so the first action will have 9. So D of... D sub 1, n or whatever. If n is 1, then D is 9. But then let's assume that so we have currently, let's assume that we have an average of 5 abilities. We'll drop down, we'll do the average math instead of the max math. So we'll do average math. Man, it's under 1 gig, that's pretty nice. I think it'll, to be clear, I don't think we'll actually end up hitting, what was this calculation again? 5 gigs of memory. I don't think that's going to happen. just because there's not going to be enough enemies with enough variations. Like most of the basic bitch enemies will only have like 2-3 abilities, so only the really advanced ones are going to get a lot of action opportunities. So it's going to skew a bit more lower on average. It actually will probably skew like 3 or 4 on average, but I'll keep it 5 for now. Nice middle point. And then what we'll do is yeah, this okay. So let's say that we have 4 actions on a zombie. We have a basic walk, or let's do 5 actually. We'll make them advanced. We'll have a basic walk. We'll have a slash, which we'll only consider relevant in the 3 possible directions that the player will be. So if we can imagine the ring around an enemy, those 8 tiles. Is it 8? 1, 2, 3, 4, 5, 6, 7, 8. It is 8. Let's drop the 9 down to an 8. Because technically there will be some abilities that do have a center point, but those abilities will probably only have a center point, or it'll be defaulted to whatever direction you're facing. So we'll set it to 8 actually, which will help a bit with our math. Wow, that's already so much better. Did that number really change? That was like a 200 difference. Okay, that's crazy. Okay, so that to 8. So we'll say the second ability has 3 possible avenues. So if we imagine the 8 tiles around a square, the 3 on the top, we're counting diagonals. So the 3 on the top, the 1 on either side, and then the 3 at the bottom. Let's imagine that a sweep attack picks a center point, and then we'll also hit the 2 adjacent tiles. So that way you can't like dodge the side and dodge it, right? So if you do a claw attack, then you'll hit 3 potential tiles. So there are going to be 3 valid spaces where there will be overlap, right? Because if we can imagine it's top center, then there will be one that's center point is top left corner, one that's center point is top right corner, and one that's top middle. So it'll be 3 attacks that are viable to hit the player. Then we'll have action 3 will be a bite, which will only have 1 valid direction, the one the player's in. And then that's just like a little like a bite attack. And then let's have like a lunge grab for our 4th ability. Let's say the lunge grab is like a charge forward kind of thing. Like it just shoves, it picks a direction. So we'll say 8 directions. This needs to be 8 as well. And he just shoves forward that way. And maybe it gets like it's like a move into like a grab attack or something. I don't know. I'm trying to think. But let's say that we have these 4, and let's do a 5th attack that's just a eating. Like if you're over a thing that you can eat, you just consume it. So these will be our 5 actions. If we take the amount of variations that we can get off of this action, then we could assume a ratio for the general unit. So what I mean by that is like we're not actually going to allow 8 possible valid options. So if we remove the non-valid world states, how many world states could we actually end up with? So we're trying to get a closer number to what we could expect it to be, so I know like mentally where to be with this. So let's do okay, so it's going to be 8, 16, 24, 32, 40. There would be 40 variations, and we only used 8 plus 3 plus 1 plus 8 plus 1, 21. So divide that by 40, it's a 0.5253 technically. So we'll apply a 53 time 0.53 ratio to this. Whoa, I did not mean to do that. Let's undo that. Okay. Let's copy this formula instead of the value. And then we'll set this to where do we put the multiplication? The number of valid actions would then be checked across it. So you would put that inside here. So you do 0.53. Because you would otherwise be multiplying this by 1. Undoing until I can go back to whatever the fuck was before this issue. Okay, we're back. Don't know what happened there. Let's add another item expression up here. Copy, paste this. We'll change this to F3. And then all we'll do is 0.8 inside this. And we'll set this to F3 of X. And we'll make another one. Why is it undefined? Shouldn't it be less than that? Or no? I guess... No, hold on. It should be less than that. Why is it undefined? Because it's less over here on the future stages. Oh, wait, this needs to be 3. That's the issue. And then we're going to set this equal to 0.53 dn to the a. Okay, so we've about cut it in half, which makes sense. We should theoretically be able to do the same thing here. We would just click this, add an expression. Not 4, 3. There we go. I was like, why is that negative? Okay, that makes sense. M1, 10, 6. Okay. Oh, this needs to be 80. 0.53 ADN. There we go. Okay. Yeah, that's much better. And so that's assuming 50 enemies. N equals 5. Let's up it to 10 real quick. Okay, we get up to gig. I hate the fact that depth 2 is an entire gig. There's gotta be a way to cut down on this. Let me go back into here. Does OBS track with me? No, it didn't. Okay, let's pop that off. Go. If we... Okay, hold on. The stream visible notebook is above. Yeah, okay. Let's say you were able to see that while Chrome was happening, right? Yes. Okay, good. Is there a way we could shrink these? So one theoretical way is we make health offset or health diff. If we know our health is small, then health diff can be shortened even more. Same with position offset, right? Like, let's say there's not many abilities, really none, in the game that are going to teleport you 100-something tiles away. And if it does, we're probably going to have like a unique thing that like feeds an int position or something. Or we're going to find some unique way to fucking do this, that it's just going to teleport us to a particular tile as opposed to a particular position. Because it'll probably be like an actual teleporter in some regard. And so yeah, that'll need to fucking launch you, and we're not going to fucking store that variable. So with this, I think you could technically store the position offset. If you split... Hold on, let me do the math real quick. You would have... if you have 4 bits, 1, 1, 1, 1 is equal to 1 plus 2 plus 4 plus 8. And so that is going to be oh, but you'd have to have 1 byte reserved for positive or negative. So it would actually be 1 plus 2 plus 4, which is still a difference of 7 tiles. So it's a 49, a 7x7 grid, basically, of possible tiles, because you would have a plus or minus. And then you would have that. So what you could do is you can technically store an S byte 2 as in a single byte as a bitmap, where it's the 1 and 5 are positive and negative, and then 2 and 4 are X, and 6 and 8 are Y. So yeah, you could do that, and that would be, you'd cut this value down by 1/3. What would that come out to? If we went back, that's the right notepad. If we scroll back up, that would cut that down from Because I was doing 25 now, so if we did 25 times 2, which is 50, plus this would now be 2 times 50, which would be, or 2 times 25, which would be another 50, as opposed to 75. And then that would be plus 100 for the action. And then ooh. Hold on, I have an idea. We might be able to cut this down more. Plus 100 for the action, plus the 2 would drop that down to 202. So that's 202. Which is a pretty noticeable improvement, I think. Because I think we're at 227, yeah. So that's going to get... $1020. Down to 930, so we took out about 100 megabytes. And then... yeah, I think we can simplify this. So one of the things that I was thinking about doing with the behavior system data, which I half did, mostly just for convenience in coding, was I thought about slicing the arrays, because all of these arrays are going to be size 255 or 256, right? Because we're supposed to store like each agent will have this value, right? So it'll have a position, and it'll have its agent data, and it'll have an ID sorted by speed, which means there'll be at least 200 or at most 256, and there'll be turns to take this round, which is how many turns that agent will take this round, which is just a 256 collection where each index is the agent. And then we have the archetype. And so what you could do is you could do that here. The reason that it's different here is that you're never updating these once they're created, right? Like I'm updating agent data depending on if your stats get modified. I'm updating position all the time, and updating that struct over and over again is going to be fucking annoying inside without having like the index reference, right? Or updating a property of that, I should say. But with the world state, they're going to be read-only, basically. So if we make a public struct called world slice, the reason this is important, here's why this matters, is because now we can only have to reference the ID once. Because now we can do public short value. We can do public byte ID. I'll change that to ID just, and then we'll do public s byte health diff, public byte direction. And then we'll do public action arg action. But then when we go into action arg, actually, we'll just delete it here. That's fine. So now we'll use action arg's action to indicate to us what the ID is. Because one of the things that I've done is, or I'm going to make a habit, I think, is because it's not nullable, right? Because it's a struct. What I'm going to do is I'm going to have action ID be our null check. So I'm just not allowing the action 0 to exist. Theoretically, I might run out of actions. Because there's 255. I think I'll be fine. I don't think there'll be enough enemies for that, and if that happens, I will deal with it when it happens, which means that all I'll probably do is make agent ID the null check, and then just shift the player up from position 0 to position 1. To be honest, that's probably what I would do. But I think this works because there's going to be a lot of actions that function identically but have different feed data, and that's not stored in here. That's stored on the enemy archetype data, right? So like a vampire swinging his sword and the zombie swinging their claw attack will have different properties, right? They'll have different damage. They might have like a different weapon type or whatever, if that's a relevant factor, or different damage types. But that has nothing to do with how like the math is actually done. And that will be, and all I'll do is just feed that as an arc as like base swing or something like that, because the functionality will be identical. And then because of that, I can cut down on a lot of the actions. So even though they might feel unique, the bite might just be like it might just be a visually and abstract wise a lunge that half the enemies have or whatever. Now we can add unique behavior to them. Ow. Fuck me. I just pulled some hair on my headset. Ow. We can add unique behavior to them. We might even be able to set up like chains of like ID 0, then ID 1 or something. I don't know. I'm still having to think about it. I'm probably have to change the actions again soon because I haven't implemented an idea yet that's gonna modify that a bit. But for now, at least the idea at least exists that the ID can be stored in the action, because the action ID or the agent ID is always in the action arc, and that way we can cut down on 2 bytes worth for this. Because now instead of having health set and offset, what we'll just do is we can just bam. Public. What did I have these at? Unsafe lists. Public unsafe list of type world slice. We'll name this something better. Let's name this like world offset. So that's like the discrepancy in values, basically. Yeah, and now I think this will be significantly less memory, but let's double check. So this would be 50 times n, where n is 2, 1, 2 plus 1 plus 1 plus 4. So 8. Okay, which means this is 402. Oh, wait. Value's not supposed to be there. That's what world state's for. All we're doing is these 3. So it'll be 7. Or no, 6, which will be 302. How did we grow? Did I do the math wrong? How did we get bigger? Weren't we smaller a second ago? Because it was It was 25. Oh, I doubled it. It was 25. Hold on. Okay. So 25 times 6. So 150. Yeah, okay. So that'll be 152. Yeah. Okay. So then we're gonna add a. We're gonna click U. We're gonna add a new graph. M3 is equal to 152. Get a new one, copy it over, paste it, swap this to M3, copy, paste it, swap that to M3. I guess if I can't see anything, I might as well just expand this, right? And then let's do the same thing on this. Actually, let's place that here. Okay. Let me rename this to M1. Rename this to M2. Then drag that back down. Because as we're getting smaller, do it this way. So yeah, hold on. This was gonna be, if we split that byte. Oh fuck, did I not re-enable the, I did not re-enable the thing. God damn it. Such a bad streamer. Okay. If we re-enable the I'm gonna plan this out, and then we're getting to like code day 1, and I'm gonna be like, oh fuck, I need another 4 bytes per world state. I'm gonna have to completely rethink this. I can feel it already. I'm probably gonna start implementing like a really shitty zombie tomorrow or the day after, and then kind of just do the what was this version we called lethargy or lethargy? How the fuck do you say it? It's lethargy, right?
Lethargy.
No shot. Because it's lethargic.
Lethargic.
Lethargy.
That's bullshit. That's so bullshit.
Lethargic.
Uh-huh.
Lethargy.
Fuck you. Just fuck you. You know that? Okay. Okay, so we set this to M1s and M3s. And then let's make 2 more. We'll copy this. We'll copy this here. We'll copy this here. Then we change that to M2. And we change that to M2. Half a gig at depth 2 is still brutal. And the other fucked thing is, which this hasn't accounted for yet, but the other really fucked thing is that the enemies that are going to go more per turn are going to, on average, have more actions they can do. right? Because currently we're assuming everybody only gets one action, which they are only going to get one action per world state. But because enemies that are faster will have more turns, it'll be like, you know, I get 3 turns per, and I have 8 actions. Well, the zombie only has 1 turn per, and it has 5 actions. And so there's gonna be this weird factor of the fact that yeah, that's gonna be fucking annoying. Okay, hold on. Let me copy you to here. I want to move this around a little bit. We're gonna copy F2 or F4, F2 and 2 to here, and then we're going to paste, and then we're gonna copy M2 to there. We're gonna copy F2 to 3 to here. Ugh. Maybe we can curb how much we process the future turn, right? Because of every valid action that you do, there's gonna be like 5 ones that we consider like the top action that you can take right now, right? It's not like in chess, or I don't think it'll be like chess, where there's gonna be this like checkmate in 7 that if you had just seen, you would have got there. Maybe that'll happen every now and then, but the vast majority of game states are going to be, the move set's going to be fairly obvious. So maybe, and if it wasn't obvious, we'd only want to know that once we'd hit a sufficient depth, right? Like, the moves that where it's going to be like, oh shit, there was a checkmate here, are if you like ran it like 9 moves deep. So you're only gonna, we're like 7 moves deep, and at that point it's like, okay, we can't even entertain this as a notion right now. So ignoring those, if we curb the top 5 results to be done into the next state, right? Like let's say we have a cap of like 5, such that, okay, on X is 1, we generated 8 times 10 to the 50th. Okay, we're going to pick the 5 best states, and then we're going to do the exact same thing on those again. I wonder if we set a cap like that. Let's add an item. We'll make an expression. Because that's going to radically decrease the number of world states, which is going to, hopefully, increase our... So we'll set C equal to 5. So this means that we're going to look at the top 5 actions and their consequences back and forth. Man, if I want to get really tricky with this, I could technically import another variable, name it like P, and set that to 10, and that's the number of player actions. And then I could make it such, I could do a modulo multiplier, such that on even turns, we count that one. You know, on enemy turns, we count the other. And so that way we could try to get like a back and forth analysis of like tracking what the player can do versus like what a shitty zombie could do. That could be interesting. But for now, let's not do that. We'll set C equals 5. We'll set this as a range between 1 and, I don't know, 50. And then what we'll do is we're going to implement the function again. Or no, we're gonna need a variation. So we'll create another expression. By the way, Desmos is one of the best things to ever exist. I remember using this in fucking middle school in order to pass my algebra classes. Love Desmos. Desmos is so fucking nice. Okay, so this is still going to be, we'll do a dn of a, and then we're also going to we'll do another one. That'll be f of 7. We'll keep with this odd and positive theming going, and that'll be 0.53 dn of a. Okay. Okay. And then we're going to set f of 5 is going to be equal to f of x, but we're going to multiply f of x minus 1 times, how do we cap the value? Is there a min or a max? Because it still needs to take in the previous. Well, no, it doesn't need to take in the previous. What it needs to do is it needs to set it to, instead of f of x minus 1, it needs to set it to 5x. Because it'll be 5 at each x stage. Oh, this needs to be x minus 1. Okay. Yeah, so now the 1 will stay the same, because it'll actually work, because it only does this on the recursive formulas, and then we'll see variation. So like on f of 5, this would be the same as f of 1. Yeah, we cut out 50 degrees. Okay, let's do, I think I can officially say we're not using 452. So I don't think we need M1 anymore. So we're going to replace the M1 calc with the F5s and see where that winds up. Let's change this to 5. What was f of 3? Oh, that's to the 0.53. Okay, let's do... And then we'll do the same thing here. Oh, we need to make, let's add a new expression. Paste, name the 6, steal the min section. Name this f6x, and then we will do the exact same thing. Yeah, that's how recursive formulas work. What is the issue here? F of 8 of x is equal to min of f of 8x minus 1 comma 5 times 0.5. This is literally the same thing. We just copy, paste, place with the 8. Oh, maybe I need to, hold on. I see the issue. Put a 1 here. There. Then we need to turn that to 0.53. So that way we can replicate the formula correctly. And okay. Now, I don't care about the M2s that right now. We're just going to do M3s because that seems like it'll work. F3. And then we're going to just go into here, change that to 6. Go into here, change that to 8. Delete. Delete. And I guess, theoretically, it doesn't have to be a static 25 items, because we can just scale it with how many are in the region. So if it's a particularly big region, then we can scale it up to 30 or whatever, and then if it's a really small region, then we can scale it to whatever is appropriate. Actually, let's do it this way. Let's get rid of M2, and we'll set this to because I don't think M2 matters at all anymore. Yeah. And we'll create a thing called, I don't know, no, we already have D. We'll do S for size, and we'll set S is equal to what's the size of the struct? Or no, actually it's the offset, so we'll name it O. There we go. The offset is, I left my Desmos open, right? Okay, good. You guys can see that. We'll set offset equal to, it was 25. No, that's the size. What was the byte count? 6 bytes, right? Yeah, 6 bytes. Okay. So we'll set O is equal to, well, no. This is the amount of worlds. So we'll set amount of enemies in the region. So I guess we could just set that to, we could just build off A, actually. So let's cancel this, get M2 back in case we want that later. And then we'll just set M3 is equal to A minus 1, technically, because there's not an enemy there. It's going to be the player. A minus, well, no, the player will still have stuff until we specify that. It's fine. A times 4A, right? Or no, 6A. And then I think we agreed to drop this down to 25 for most, which is gonna help a lot. What was the reason F4? Oh, that's right. We incorporated the idea of filtering out some of the actions. And that drops it down to 170 megabytes. That's big. Oh, shit. That's even bigger. What is this? What did these look like? I gotta wonder. Yeah, the issue is that just the world state has too much. You have to create too many world states for this to matter. It'll scale flatter, but like when you're starting off at 8 times 10 to the 25th, and you have to make 5 versions of it for each strain forward, it's still, you're still fucked. And honestly, this is just how many world states we'd process up to a length, assuming that we only stayed within those 5 confines. We'd still technically have to have the rest in memory. This will just be how many are processed. So this isn't even really correct. Unless we were cutting out the ones that beneath that top 5 at the end of each world state. Which I guess we could do, theoretically. Okay, I feel like we're gonna start hitting the limit of this napkin math. But I think either way, the idea that we're only processing 5,300 world states is actually really nice. That would be crazy. So I think Okay. Yeah, I think our napkin math is coming to a close. Let's look at the OBS, or not OBS, fuck. Let's look in here. Let me turn that off in OBS. Go pull this notepad up. So theoretically, for 25 enemies, we can keep the memory at 152 bytes. That's pretty good. And then what we would end up doing, if we, assuming we kept like a cap of 5, let's say. Although cap of 10 is probably best. No. Do you know what we should cap it at? Ah, fuck, we can't do the 5-man cap. Fuck. We could only do the 5-man cap, or the 5-value cap. Hold on, we're going back to Desmos. We're going to do the 5-person cap if we were doing these functions, not these functions. Because these conceptualize every enemy's move, while these would only give us 5 of the enemy's moves. So we actually need, instead of us using C on our values, which actually I need to put C instead of 5 here. I don't know why I did 5. This needs to be a minimum of 2A or like 3A. Because it has to be the number of enemies and like their top 3 actions, right? Because what you don't want, whatever it is you end up doing, you do not want the number of enemies, or you don't want an enemy to get to the point where it's its turn and you cleaved away all of the turns that it would have taken. Because what would have happened here, right, is that whatever unit is in the best position would get the top 5 evaluation states and then ignore everything else. And that would break the fucking AI. So you can't actually limit by 5. Here you have to limit by number of enemies. Up here you can limit by the width that you want them to be. So if we did CA, that would be more accurate, which is 60 megabytes. And then if we drop C down to like 3, can I say steps in 1? Does that mean that it'll yeah, it does. Okay, I need to make sure I do that. Step in 1, steps in 1, steps in 1, steps in 1, steps in 1. Oh, wait, so I can actually, no, this is fine. I'll keep that 28. So yeah, I can actually just, it's so much nicer. Okay. So if it's C is 3, did I do that for this? Yeah, okay. So C at 3, that means we'd be at 36 meg versus C of 5 is 60 meg. Okay. Okay. Wait, I don't think it'd be CA. It's going to be CAX, right? Because you're having to. I think it'll be CAX. Yeah, because you're still going to have to multiply. You're still getting the minimum of the number of Or to be CA to the X. So what we're saying is that at X is 1, we should actually have the top... at X is 1, we're keeping the top 5 states. Or what do we do in this case? The top 3 actions for each unit. Then when we get to 2, there's 25 enemies. We take the top 3. We should start with 75 times the amount of turns that we consider. And so A, D, and N is going to be... Nope, not notepad. I need to pull up a calculator. I don't want to do this math. Calculator. 25 times 10 times 8. It's going to be 2... I think that's the right number. Yeah, 2,000 actions. Yep. And then we're going to multiply that by C times A, which is going to be, in this case, 75. So that'll be 150,000. But then when we get to the second one, if we still take the top 75 of this, or no, I guess it's clamping it back down. We're non-exponentially truncating it, right? It's not like we're cutting off a branch. We're trimming it down to 5 branches the whole way through. So I guess actually it would just be C times A. Yeah, that is actually correct. Okay. Granted, in practicality, if we waited more time, or if we let it run indefinitely to whatever depth that we set it to, let's say it was depth 4 or whatever, or in this case we're setting it to depth 3, that by the time we get to 3 and we come back, that when we come back we're actually going to have fuck, I'm blanking now. I completely lost it. When we come back, we're going to have it's gone. I can't tell you. I actually can't tell you. It's fucking gone. Okay. Whatever. Okay. And then we said, oh, this was at 10. If we set this back down to like, what, 7? Okay. And back up to 50. 100 megabytes. 150 meg. That's much better than where we started. Listen, I think right now my opinion is tomorrow we're going to start implementing a shitty one. Just kind of a basic bitch enemy. And then what we're going to do is we're going to kind of see where this sits. Because I think... So, one thing that can help, which I haven't thought about too much yet, was that when we were discussing these mood states that the enemy could be in, I was talking about weighting the actions. What we could actually do to speed this up is just not attached to each action which states you're allowed to do them in. Or either of these, right? So suspicious of player, if you're suspicious of the player, you're not going to be eating shit, right? Suspicious of the player means that you're going to be like looking into something, you're going to be seeking something out, or you're going to be running. You are on guard in some way. But also similarly, if you're a zombie, and you're effects like hunting abilities, like sensory effects, those aren't. Why would you ever consider doing those in these other states? So what we could actually do is we could filter out the actions only to the ones relevant to the current state, and similarly we could filter them out only to the ones relevant to the current mood. So I'm imagining for like a really complex enemy, like a boss. Let's imagine that it's like a sadistic torture boss, right? This fucking crazy brutalist motherfucker. If his two modes are sadism, and then we'll say it's sadism, and then once he's been beaten some amount, then he panics because he's like, oh fuck, I can't keep torturing you anymore, and you're actually gonna fuck me up. And the second one's fear. Some of his most mobile actions are not going to be taken during sadism because he's gonna want to like fucking relish it, and he's gonna want to fuck with the player, and he's gonna want to move slowly and kind of freak the player out, and he's gonna, slowly stalk you through the halls and shit. Like when he's trying to fuck with you, it's gonna be sadism rather than fear. And similarly, there's going to be actions that you take, like trades that enemies are going to consider that are never going to make it to the chopping block in non-anger modes or in non-thrill modes, or checking up on an objective as an action is going to be something that's that commitment is going to do more than any of the other ones. So I think in some way we could cut down, even if like the zombie ends up having 8 or 10 actions, right? You would still only maybe process 4 or 3 at a time, which should hopefully bring down our numbers a good bit. Because 10, I don't think anybody in the game is going to be processing 10 actions simultaneously. That is just a bit too high for what I'd expect. I'd expect something closer to like 3 or 4. And even then, we're going to have that 0.53 estimate of like, how many actions are actually valid. Some actions, unfortunately, I think might have more than 8 directions. So one could imagine a smoke bomb could technically be thrown in a wide plethora of tiles. The direction, quote unquote, you throw it at is just going to be offset of your current position to where you're throwing it. So that might end up being way more, and we might have to find a much better way to curb that one. I think with this byte split idea that we were fucking with, I think that still got down to, was it a 7x7 grid or 8x8? Because, well, one, if we assume that 0, 0, hold on, let's do this out, right? Let's say we split the byte, and each 4 bits is one direction. So we have the first bit, is going to be the sign, right? It's an S half byte, right? Then we have 3 bits. Okay. If we have 0, 0, 0, oh no, we do have to have 0, 0, 0 as 0, because you might only move one axis. So no, we still have to keep 0, 0, 0. But that means that our max is now 1, 1, 1, which is going to be 7. So we have a -7 by -7, or -7, -7 to 7x7 box of directionality with this truncation, which will be fine. Let's see. So yeah, there'll still be a 40. Shut the fuck up. There'll still be a -7x7 to 7x7 grid that the enemy could throw an item towards, which would still be a good amount of variation that you could do. So at most, theoretically, there could be some ranged attacks that go up a good bit in directionality, but what we could also do is we could probably um, like let's say it's a bomb, right? The bomb is only going to have 9 spaces of overlap for the player. Technically, we could even say 8 if the bomb's not allowed to land on the person. So in a way, we'll still have the same number. Or similarly, if in an arrow, maybe the arrow fires in a particular direction and doesn't have and only keeps like we only like give it the narrow wedge that it could shoot the arrow at, right? So it's like direct on target, a little to the right, a little to the left, and then like maybe like a 1 or 2 far angles or something, just in case they like player dashes or something like that. So you can kind of build out like an idea for what the how the character might snipe the with the bow. Um, okay. I'm pretty tired and I got work tomorrow, so this is this was a bit more than I thought I was going to be doing tonight in terms of the meme term premature optimization, but the goofy term, but we still have I have a much better idea of the scale I think we can get away with cuz this shit cannot stand. This shit's fucked. Um and also, I'm so glad that I didn't end up writing out like a basic picture version that contains the consider all the enemies and then plot that over the variations thing. Because I was trying to figure out how I was going to code it. And I was like, how the fuck am I even going to code throwing together like multiple enemies and then cross like pollinating out like all of the. I was trying to figure out it was going to be some weird index math where it was going to be like, okay, for these are our indexes for each of the units, and then we're gonna try to like start like slotting them in at a particular point, and we're gonna like let it overflow so that it can go back to the beginning of the array and some fucking meme. I don't know. Um, but yeah, this is good progress. I think it's at least a good idea. I feel like this is what I should aim for because 25. Oh, this is still set to 50. Um, I just don't see 25 enemies being active in a region at the same time. I just don't. I don't see it happening. Um, okay. Um, got lost in thought. Okay. I think that's gonna be it for me tonight. I'm pretty tired. So, let's call it. Thanks for hanging out, guys. Appreciate it. See you guys around.